machines are largely human-powered. They're largely from the early to mid-1800s, and they are all transplants from Providence, Rhode Island, which is where the jewelry industry and the industrial age started in the United States. Because I already was in the jewelry industry, I saw that there was an economic opportunity there to gather this artwork and the machinery that processed it and bring it back to Harrisonburg and do something that was commercially viable. And so that's what this is. For most of this stuff, there are no manuals. There's no parts list. There's no shelf of parts that I can order from. So almost all of this needed to be fixed. And so that's always been the most challenging part of it.
We have many levels of engagement in the machine shop. Besides being the service facility, we help with the Department of Engineering's design sequence and teaching sophomore design students the lathe and the mill, basic manufacturing techniques and stuff. And then we have what is it's a 2-year apprentice program, where I hire 4 juniors and 4 seniors a year, but they learn machining and manufacturing through a quilt-like work pattern. They learn on-the-job training. Our association and project with Hugo is a very small microcosm of a capstone project that an ordinary engineering student would pursue. The engineering department goes out and they solicit clients all across a broad range of specters, and those clients bring in their engineering problems, and then so groups of capstone students try to gather together and solve those problems.
They're helping me tremendously, and so the way I came to Mark was working on a project, independently on my own, and coming to roadblocks of, well, I don't have knowledge to go any further. And Mark showed up here with a couple of his apprentices, and we went through an interview process. They're using what I'm telling them to fashion more questions, so they're helping me communicate to them in a way that they can understand what I need. And so we've completed one project that has worked, immensely well. And we started with something that had historical importance, that had artistic importance, and had a tremendous provenance. But there was a missing mechanism in between the artwork and the machine to process it.
They required a bit of SolidWorks, CAD work. They created models to project how the movements would work. The solution to Hugo's problem was creating basically, it's really just a little simple polyurethane plug that they had to calculate how much compression they could achieve out of it without a significant amount of distortion. So they had, basic engineering solutions, but then they also had manufacturing applications that they also had to apply.
And so the project that we did, to me, not only to me was exciting, but it's a project that should be exciting to the world. Because we took artwork that was almost 200 years old from an important company that was one of the great art houses of America, and they fabricated the missing mechanism between the artwork and the machine that processed the artwork. And so they allowed us to bring artwork back to life that has not been used for almost 200 years. And so for me, as a person who loves to make things, that was immensely important.